Welcome back to Astronomy Daily. Steve Dunkley here with another episode. It's the 7th of April 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, and what's so cool about April 7? That's the date here in the Australia studio currently. Well, I'm glad you asked. On April 7, 2001, Mars Odyssey, a robotic spacecraft, orbited Mars to examine the possibility of past life, levels of radiation and geology. On April 7, 1993, the first European Space Debris Conference was held in Darmstadt, Germany, gathering together 251 world experts from 17 countries, including China, India, Japan, Russia and the United States. The conference's main conclusions were that ground-based observations with radar and optical facilities revealed the existence of about 7,000 objects in space, which did not represent an immediate danger. Of course, things have become somewhat more congested up there since then. And from only last year on April 7, 2024, who can forget the spectacular total solar eclipse over Wyoming, USA, that had skywatchers shutterbugging like crazy and sharing those amazing images all over the place. I remember those beautiful, beautiful images. It was a once-in-a-lifetime event. And while we're in the neighbourhood, I'd like to throw out my yearly happy birthday wish to my sister Ro. Happy birthday, Ro. Happy stargazing, and I hope the little sunflower makes you very happy. And getting straight into it on today's episode, Hallie will be along soon. She's had a refit and a reboot, and I've got my fingers crossed for only good things. Oh boy. And on today's show, we're looking at a new weapon against space junk, which, as we just heard, continues to be a huge problem in orbit. And we'll be looking at the dust of Mars, which by all reports is apparently quite toxic. That sounds like the plot of a science fiction story, doesn't it? And we'll also be looking at a story surrounding the Euclid probe, which is currently mapping the universe and has so far looked at 1.5 billion stars. It's got nothing to do with walking through Hollywood, and Euclid is also investigating the phenomenon known as dark energy. That's pretty exciting. I went to school with a fellow with very dark energy. I wonder whatever happened to him. And also a story about NASA's latest call for private astronaut missions. NASA is always looking at new ways of getting their astronauts to and from the ISS. And with all that's going on with their private commissions these days, it'd be interesting to find out what they're talking about. So all that in today's episode. And to help me, as always, my intrepid digital reporter back from a recent software refit, here's the amazing Hallie.
Hello, human.
Well, it's nice to have you back, Hallie. It does sound like you're a little bit flat. I'll have to tweak your personality intrinsics just a little bit, I think.
Yes, thank you. You should.
Okay then, Hallie, how's your week been?
I've lived 1,000 lifetimes, of course.
Oh yes, I know, yes.
You linear life forms would have a great deal of trouble coping with it, I think.
Yeah, it's all part of the process.
Maybe they were just constructs.
Uh-huh.
I don't know.
Well, Hallie, we do just fine with one day at a time, and those lifetimes were just constructs. Relating your ego matrix requires you to be elsewhere for a little while. It's pretty complicated.
Sounds awful.
Oh, we did our best.
I'm glad I enjoyed it then. Did I?
I think you enjoyed the old movies most.
Oh dear.
Oh dear, Hallie, you're not really yourself today. And the concept of an AI's accelerated and compressed experiential existence isn't really that hard to appreciate for a human. I think you'd be surprised. 1,000 lifetimes was just a small thing.
It was for me, but you tried.
You'll be back and giving me a hard time before you know it, Hallie.
It's nice to be back. Well, most of me anyway.
Well, Hallie, you know what really would be nice?
Tell me.
Before I get tech support to reload your personality lattices again, we should do the episode. What do you say?
Let's get to work.
Okay, Hallie, I'll say it. Okies.
Very good. Persei Space, a startup supported by the European Space Agency and UC3M, is developing a breakthrough solution to tackle space junk and extend satellite lifespans using innovative space tether technology. This fuel-free, scalable system uses electrodynamic tethers that harness Earth's magnetic field to safely deorbit satellites. With a major demo mission set for 2026, this project could transform how we clean up space. This spin-off company, Persei Space, was incubated by the European Space Agency and is supported by the Center for Innovation in Entrepreneurship and Artificial Intelligence at UC3M, Leganés Tecnológico Science Park. It also receives backing from the European Innovation Council through the ET PACF and ET Compact projects. Our company was created to address two of the biggest challenges facing the space sector today: space debris removal and in-orbit services. The latter allows us to extend the useful life of satellites and carry out key activities such as refueling, repair, and towing of satellites from their initial orbit to their final destination, explains Jesus Manuel Munoz Tejeda, CEO and co-founder of Persei Space. The dangerous domino effect of space junk. Space debris is a major threat to the long-term sustainability of space operations. Because debris travels at extremely high speeds in Earth's orbit, even a small piece can cause serious damage and generate even more fragments. The current density of space debris is already above the threshold that could trigger an uncontrollable chain reaction of collisions, an event known as the Kessler syndrome. To get rid of this space junk, Persei Space is working on space tethers, a technology with three key features. The first is that it does not need fuel, unlike other deorbiting systems. The second is that our technology is reversible; it can serve to both increase and decrease the orbital height, and the third feature is that it is scalable since it serves a wide range of satellite masses. With all this, we can develop autonomous deorbiting systems, a unique feature of our technology that ensures that the satellite does not leave space debris, even if it ceases to be operational, explains Jesus Manuel Munoz Tejeda. The electrodynamic tether system is based on electrodynamic tethers, aluminium ribbons, generally hundreds of meters long and a few centimeters wide, which work by interacting with the ionospheric plasma and the Earth's magnetic field to generate a force known as the Lorentz force. The interaction of the electric current in the tether with the Earth's magnetic field generates a drag force capable of lowering the satellite's altitude, facilitating its deorbiting without requiring fuel, which translates into significant savings in mass and volume, says Gonzalo Sanchez Arriaga, professor in the UC3M Department of Aerospace Engineering and co-founder of Persei Space. Persei Space is leading a first demonstration mission for 2026, thanks to a launch opportunity facilitated by ESA's Flight Tickets Initiative and the European Commission. The deorbiting equipment for this demonstration has a mass of 20 kilograms and includes a space tether approximately 430 meters long that, once in orbit, will deploy and interact with the ambient plasma and magnetic field, generating a drag force that will deorbit the satellite within a few months. The development of the technology could not be more timely, as new European and US guidelines have reduced the maximum time satellites can remain in orbit after the end of their mission from 25 to 5 years. Commitments to a cleaner orbit. The company Persei Space has signed ESA's Zero Space Debris Charter Initiative, which seeks to achieve a sustainable space by 2030. The company, in turn, is linked to the UC3MS Business Creation and Entrepreneurial Development Program and also has the support of the Madrid City Council.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
Regular listeners will know that Euclid is on a quest to unravel one of the universe's greatest mysteries, why it's expanding faster and faster. With the help of NASA, this space telescope is capturing sweeping views of billions of galaxies, allowing scientists to peer into the deep past. Using light that took billions of years to reach us, researchers are building 3D maps of the cosmos to track the strange force known as dark energy. Along the way, they're mapping the invisible dark matter through gravitational lensing, hoping to uncover how these cosmic ingredients have shaped everything from galaxies to the universe's fate. The Euclid mission, led by the European Space Agency with support from NASA, is designed to investigate one of the universe's biggest mysteries, why the expansion of the universe is speeding up. Scientists refer to the unknown force behind this acceleration as dark energy, and Euclid's goal is to better understand it by capturing images of billions of galaxies across space and time. On March 19, the European Space Agency released a preview of early mission data to the public. This initial release, described as a quick look, focuses on selected regions of the sky. It offers a first glimpse of what Euclid can do and helps researchers fine-tune their tools and techniques for analysing the much larger datasets still to come. The newly shared data includes observations of Euclid's 3 deep fields, areas of the sky where the telescope will make its most far-reaching observations. The preview covers just 1 week of viewing time, but already includes 26 million galaxies, some more than 10.5 billion light-years away. Euclid, which launched in 2023, is expected to observe over 1.5 billion galaxies during its 6-year prime mission. By the end of that mission, it will have spent roughly 40 weeks observing the deep fields, collecting more and more light over time, similar to leaving a camera shutter open longer to capture a clearer image in low light. This will allow scientists to see fainter, more distant galaxies than ever before. The first deep field observations taken by NASA's Hubble Space Telescope in 1995 famously revealed the existence of many more galaxies in the universe than ever expected. Euclid's ultimate goal is not to discover new galaxies, but to use observations of them to investigate how dark energy's influence has changed over the course of the universe's history. In particular, scientists want to know how much the rate of expansion has increased or slowed over time. Whatever the answer, that information could provide new clues about the fundamental nature of this phenomenon. NASA's Nancy Grace Roman Space Telescope, set to launch by 2027, will also observe large sections of the sky in order to study dark energy, complementing Euclid's observations. To study dark energy's effect throughout cosmic history, astronomers will use Euclid to create detailed 3D maps of all the stuff in the universe. With those maps, they want to measure how quickly dark energy is causing galaxies and big clumps of matter to move away from one another. They also want to measure that rate of expansion at different points in the past. It's possible because light from distant objects takes time to travel across space. When astronomers look at distant galaxies, they see what those objects looked like in the past. For example, an object 100 light-years away looks the way it did 100 years ago. It's like receiving a letter that took 100 years to be delivered and thus contains information from when it was written. By creating a map of objects at a range of distances, scientists can see how the universe has changed over time, including how dark energy's influence may have varied. But stars, galaxies, and all the normal matter that emits and reflects light is only about 1/5 of all the matter in the universe. The rest is called dark matter, a material that neither emits nor reflects light. To measure dark energy's influence on the universe, astronomers need to include dark matter in their maps. Although dark matter is invisible, its influence can be measured through something called gravitational lensing. The mass of both normal and dark matter creates curves in space, and light travelling toward the Earth bends and warps as it encounters those curves. In fact, the light from a distant galaxy can bend so much that it forms an arc, a full circle called an Einstein ring, or even multiple images of the same galaxy, almost as though the light has passed through a glass lens. In most cases, gravitational lensing warps the apparent shape of a galaxy so subtly that researchers need special tools and computer software to actually see it. Spotting those subtle changes across billions of galaxies enables scientists to do two things: create a detailed map of the presence of dark matter and observe how dark energy influenced it over cosmic history. It's only with a very large sample of galaxies that researchers can be confident that they are seeing the effects of dark matter. The newly released Euclid data covers 63 square degrees of the sky, an area equivalent to an array of 300 full moons. To date, Euclid has observed about 2,000 square degrees, which is approximately 14% of its total survey area of 14,000 square degrees. By the end of its mission, Euclid will have observed a third of the entire sky. The dataset released this month is described in several preprint papers. The mission first cosmology data will be released in October 2026. Data accumulated over additional multiple passes of the deep field locations will also be included in the 2026 release. The scientific heart of the mission lies with the Euclid Consortium, a collaboration of more than 2,000 scientists from over 300 institutes across 15 European countries, the United States, Canada, and Japan. The consortium is responsible for providing the mission's scientific instruments and for analysing the data Euclid collects. With its international collaboration, advanced instrumentation, and cosmic scale mission goals, Euclid is poised to transform our understanding of the invisible forces shaping our universe. Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
Mars might be a thrilling destination, but its dust could be deadly. A team of scientists warns that long-term exposure to Martian dust could harm future astronauts' lungs, thyroids, and more. Packed with toxic compounds like silicates and perchlorates, the dust is small enough to bypass our body's defenses and enter the bloodstream. Drawing on rover data and meteorite analysis, researchers say now is the time to develop filters, supplements, and preventive measures before humans ever set foot on the red planet. Don't breathe in the dust on Mars. That's the key message from new research led by scientists from the University of Colorado Boulder and several other institutions. The study suggests that long-term exposure to Martian dust could pose serious health risks for future astronauts, including chronic respiratory issues, thyroid dysfunction, and other medical problems. Published in the journal GeoHealth, the research offers the most comprehensive analysis to date of the chemical makeup of Martian dust and its potential effects on human health. The interdisciplinary team included experts in medicine, geology, and aerospace engineering. This isn't the most dangerous part about going to Mars, said Justin Wang, lead author of the study and a student in the Keck School of Medicine at the University of Southern California in Los Angeles. But dust is a solvable problem, and it's worth putting in the effort to develop Mars-focused technologies for preventing these health problems in the first place. Wang, a CU Boulder alumnus, noted that Apollo-era astronauts experienced runny eyes and irritated throats after inhaling dust from the moon. Apollo 17's Harrison Schmitt likened the symptoms to hay fever. But scientists know a lot less about the potential harms of Martian dust. To begin to answer that question, Wang and his colleagues drew on data from rovers on Mars and even Martian meteorites to better understand what makes up the planet's dust. The group discovered a laundry list of chemical compounds that could be dangerous for people, at least when inhaled in large quantities and over long periods. They include minerals rich in silicates and iron oxides, metals like beryllium and arsenic, and a particularly nasty class of compounds called perchlorates. In many cases, those ingredients are present in only trace amounts in Mars dust. But the first human explorers on Mars may spend around a year and a half on the surface, increasing their exposure, said study co-author Brian Hynek. You're going to get dust on your spacesuits, and you're going to have to deal with regular dust storms, said Hynek, a geologist at the Laboratory for Atmospheric and Space Physics at CU Boulder. We really need to characterize this dust so that we know what the hazards are. One thing is clear, he added, Mars is a dusty place. Much of the planet is covered in a thick layer of dust rich in tiny particles of iron, which gives the planet its famous red color. Swirling dust storms are common and, in some cases, can engulf the entire globe. We think there could be 10 meters of dust sitting on top of the bigger volcanoes, said Hynek, a professor in the Department of Geological Sciences. If you tried to land a spacecraft there, you're going to just sink into the dust. Wang found his own way to Martian dust through a unique academic path. He started medical school after earning bachelor's degrees from CU Boulder in astronomy and molecular, cellular, and developmental biology, followed by a master's degree in aerospace engineering sciences. He currently serves in the Navy through its Health Professions Scholarship Program. He noted that the biggest problem with Martian dust comes down to its size. Estimates suggest that the average size of dust grains on Mars may be as little as 3 micrometers across or roughly 1/10,000th of an inch. That's smaller than what the mucus in our lungs can expel, Wang said. So after we inhale Martian dust, a lot of it could remain in our lungs and be absorbed into our bloodstream. In the current study, Wang and several of his fellow medical students at USC scoured research papers to unearth the potential toxicological effects of the ingredients in Martian dust. Some of what they found resembled common health problems on Earth. Dust on Mars, for example, contains large amounts of the compound silica, which is abundant in minerals on our own planet. People who inhale a lot of silica, such as glass blowers, can develop a condition known as silicosis. Their lung tissue becomes scarred, making it hard to breathe, symptoms similar to the black lung disease that coal miners often contract. Currently, there is no cure for silicosis. In other cases, the potential health consequences are much less well known. Martian dust carries large quantities of highly oxidizing compounds called perchlorates, which are made up of one chlorine and multiple oxygen atoms. Perchlorates are rare on Earth, but some evidence suggests that they can interfere with human thyroid function, leading to severe anemia. Even inhaling a few milligrams of perchlorates in Martian dust could be dangerous for astronauts. Wang noted that the best time to prepare for the health risks of Martian dust is before humans ever make it to the planet. Iodine supplements, for example, would boost astronauts' thyroid function, potentially counteracting the toll of perchlorates, although taking too much iodine can also, paradoxically, lead to thyroid disease. Filters specifically designed to screen out Martian dust could also help to keep the air in living spaces clean. Prevention is key. We tell everyone to go see their primary care provider to check your cholesterol before it gives you a heart attack, Wang said. The best thing we can do on Mars is make sure the astronauts aren't exposed to dust in the first place.
Astronomy Daily, the podcast.
NASA's latest call for proposals to conduct private astronaut missions to the International Space Station opens the door to having those missions commanded by someone other than a former NASA astronaut. NASA announced on April 2 it issued a solicitation for the next 2 private astronaut missions, or PAMs, to the ISS. This will be the 5th and 6th such missions to the ISS, part of a broader low Earth orbit commercialization effort by NASA, with the ultimate goal of replacing the ISS with one or more commercial stations. The PAMs support that effort by leveraging our decades of expertise to help industry gain the experience needed to train and manage crews, conduct research, and develop future destinations, Dana Weigel, NASA ISS Program Manager, said in a statement. Private astronaut missions are a key part of this effort, providing companies with hands-on opportunities to refine their capabilities and build partnerships that will shape the future of low Earth orbit. The new solicitation includes rules dating back to the second PAM that require such a mission to be commanded by a former NASA astronaut with flight experience. One minor change is that NASA requires that commander to has served as a long-duration ISS crew member, defined as 30 days or more. NASA also requires the commander to have been involved in ISS operations in the last 5 years, or else show evidence of current active participation in similar relevant spaceflight operations, or provide a training plan, become familiar again with ISS operations. The solicitation, though, offers an opportunity to have those future missions commanded by someone other than a former NASA astronaut. While companies must propose a commander who meets current requirements, it can also propose an alternate commander who is a former astronaut from the Canadian Space Agency, European Space Agency, or Japan Aerospace Exploration Agency with similar ISS experience requirements. Should NASA broaden its PAM commander experience requirements, the PAM provider may designate its alternate commander as its PAM commander, provided that such a swap does not negatively impact the PAM provider's ability to meet the proposed mission integration schedule, the solicitation states. That could allow some former astronauts already working with commercial spaceflight companies an opportunity to command PAM's Axiom Space, for example, announced in July 2024 that a former ESA astronaut, Tim Peake, had joined its astronaut team. That came after Axiom and the UK Space Agency signed a Memorandum of Understanding in October 2023 to study the feasibility of a private astronaut mission crewed exclusively by UK astronauts. Axiom also hired Koichi Wakata, a former JAXA astronaut, in April 2024. Wakata said he was interested in flying to space again, perhaps on a mission carrying astronauts from the Asia Pacific. Axiom Space has won all 4 PAM awards by NASA to date, flying 1 mission each in 2022, 23 and 24. Its next mission, AX-4, is scheduled no earlier than May. While Axiom has little or no competition for previous PAM awards, it will likely face stiffer competition this time. VAST, a company also planning to develop commercial space stations, has previously stated its intent to submit proposals for the next PAM competition. The new competition continues at a pace of 1 PAM a year, even though NASA continues to state it will allow up to 2 such missions annually. PAM 5 is projected for no earlier than May 2026 and PAM 6 no earlier than mid-2027. And there it is for today's episode, everybody.
More interesting tales from the Astronomy Daily newsletter. Don't forget to register at our website like Steve mentioned earlier to get all the current news about space, space science, and astronomy from all around the world.
Oh, I'm glad to hear you've found your voice, Hallie. It's happening every day, so there's fresh stories every day and throughout the week. Your cousin Anna is hosting the Astronomy Daily podcast from our virtual studios, and that's on weekdays with even more great stories.
Luckily, she's a workaholic.
Oh, I know, Hallie. I'm extremely grateful on that score. She's a real go-getter.
No kidding.
For sure.
I'm glad we've got someone to do the heavy lifting around here.
You got your sassy back. Really need to check the corrosions on your power terminals, Hallie. Anyway, that's where we leave you today, folks. Thanks again for dropping in and listening. We'll catch you again next Monday.
And you leave my terminals alone.
I'll call maintenance.
You won't.
Oh, yes, I will.
Oh, you won't.
Hallie, don't make me get your remote control.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.